I think that the future of this is going to be really very compelling. The fun thing about this is it could be any single day that a paper is released that completely transforms everything forwards, or it could be a new method. I think that the future is really incredible.
Welcome to a new episode of XR and AI Spotlight, the show where we give the stage to the makers and founders who are pushing the boundaries of XR and AI. My name is Gabriele Romagnoli, I'm your host, and I'm here today with Michael Rubloff. Michael is a leader in neural radiance field, also known as NeRF, a technology that turns 2D images into photorealistic three-dimensional scenes. He has established the largest independent Discord server for Radiance Fields creator at radiancefields.com to follow closely the rapid evolution of this technology. He collaborated with leading companies like NVIDIA and Shutterstock and shared his expertise at prestigious events like SIGGRAPH in 2023. Listen to these episodes to learn the difference between various types of NeRFs.
There are so many different variations now of NeRFs, and more come out every single day.
How to edit and clean both NeRF and Gaussian splats.
NeRFs are not as editable just yet, but if you use Instant NGP, you're able to go into VR with it. From there, you're able to edit floaters away. On the side of Gaussian splatting, there's been a lot of work as well in terms of editing. Some of them are like play canvases, Super Splat. There's a guy named AnyMatter15 who has a viewer, and essentially you're able to take the resulting, PLY file. There's also apps like as well. That one also has an in-house editor for, say, removing floaters.
2 ways to view your NeRFs and splats in virtual reality.
If it's NeRFs, you train the NeRF in Instant NGP and then you just connect through Steam Link with your headset. The other way to do it is
and the latest exciting advancement in dynamic NeRFs.
So we've seen quite a few. There's 4D-GS. There is one called Space-Time Gaussians as well. You can show dynamic moving NeRFs or radiance fields and still have that level of lifelike qualities to it, which is completely mind-blowing.
But before we get into it, I want to thank our sponsor Cognitive 3D who made this episode possible. Cognitive 3D is a spatial analytic platform to improve how organizations can analyze users' behavior in VR and AR and turn the findings into actionable insights. Cognitive 3D has a handy SDK that integrates easily in Unity and Unreal. Data are collected and displayed in 3D contextually to help you improve user engagement and retention. Whether you are designing training and simulation, running consumer research, or creating games and entertainment content, Cognitive 3D will change the way you track and learn from your data. Head to cognitive3d.com to learn more. And now, let's welcome Michael on stage. Michael, it is a real pleasure to have you here.
No, thank you so much for having me. I'm very excited to be able to speak today.
So, your content focuses around neural radiance field. So what are them, and how is this technology, let's say, fundamentally different from photogrammetry?
Yeah, so essentially NeRFs or neural radiance fields were invented in 2020. And so I didn't discover them until pretty early 2022 or so. And at the time, that was the only radiance field method. So I started the website neuralradiancefields.io. But what it's ended up happening was NeRFs are just the first iteration of radiance fields. And so now they've expanded into more varieties, such as, 3D Gaussian splatting. But to go back to what, actually NeRFs are is they are what's known as a radiance field, which is being trained through a neural network. And how that is different to, say, photogrammetry is photogrammetry cannot process light as it actually occurs. In terms of like the reflections and the shadows, you don't have that lifelike quality to it. Where photogrammetry has immense commercial applications and has been like extremely developed over the last half century. NeRFs and radiance fields by extension are completely brand new, and they come with it a whole bunch of new features that weren't previously available. And that kind of is where you get those lifelike representations of exactly what it sees. And with, say, photogrammetry, you might be looking at a much longer convergence time to actually getting an output, whereas NeRFs are fast and radiance fields are significantly faster, and you get a much higher aesthetically pleasing output, whereas photogrammetry I think has a lot more commercial applications for it in its current form.
And so you mentioned about faster. Is that because I see this as a two-step process? One, the speed in getting a NeRF model, and then the speed of processing. Are they fast in both of these in terms of how fast you get it and how fast you process it, or not? Maybe you can tell us.
Yeah, so I think for the actual capturing stage of it, I think it just comes down to what the intention is. If you're going to be creating like an object NeRF, for instance, then it shouldn't take you more than a couple minutes to capture it. Whereas if you are, say, like flying a drone to capture like an exterior of a church or something, or use a more photogrammetry approach to it, it might just be a similar length and time for the capturing, but when you're actually running it through structure from motion and then putting it into a NeRF method, like say if you're going to put it into Luma or Polycam, you're really only going to be waiting something like 15-20 minutes to have that initial drag and drop into seeing the actual final product, which is really fast.
Right. So it is about what you're saying is extremely fast from a processing the capture itself.
Yes. Yeah. So once you have everything in it, it's going to be probably around, like, depending on the method, around 15 to 30 minutes.
And we are going to dive more into the methods, right? And the various kinds, because indeed, I think now that everybody can get their phone, their app, or even just a video that you have shot weeks or months ago, you can use it and just use it directly to get these 3D models. I think that is where this thing is getting really, really exciting, due as well to their accessibility. But before we are going to go into that, I'm just curious, like, what got you into this? Like, I mean, what is your background?
Yeah. So for me, I do not have a technical background. My background has just been sort of straight curiosity for this technology. And I actually, the way I found NeRFs to begin with was I was trying to create with LiDAR and using, my iPhone. I had an iPhone 12, and that allowed me to, have a LiDAR scanner with it. And back in, 2020, at the very beginning of the pandemic, my roommate at the time, kind of turned the phone backwards and was like, oh, this has a LiDAR scanner on it. And I had no idea what that meant. And from there, that kind of spawned a multi-year deep dive into the world of 3D scanning. That became my COVID hobby of just scanning everything and everyone. But the issue that I was running into is that I wanted things to be photorealistic. I wanted to actually have a lifelike interpretation of what it was that I was capturing. And what I was mainly capturing were people. And so I wanted to figure out how I could evolve photography past a standard flat 2D image and more into like an interactive photorealistic 3D environment. And for a while, I thought the answer to that was LiDAR. And then I think one day in like either February or March of 2022, I saw a post that someone had made with Instant NGP and found out, very quickly that this was exactly what I was trying to do. And from there, that kind of started an entirely new quest of how do I actually teach myself this? I didn't actually have a computer at the time. And so I managed to convince one of my friends, Sean, to lend me his computer. And then we realized that we didn't have an NVIDIA GPU to actually run it.
Not enough.
So I went out and I bought a 3080, and that short-term loan ended up turning into about 10 months of him lending me his computer, which was really, really generous of him. And, from there we took, probably a couple thousand NeRFs over the course of the year or so, and just did an extreme amount of trial and error to get it to, understand like what are the best practices, or like how many images can I use before my computer can't handle, the VRAM requirements. And so it was definitely like a rabbit hole that we went into, because when we first started as well in early 2022, there were legitimately zero resources. There were maybe like 5 or 6 people that I could find at any point on like Twitter or just on the general internet. And we had never interacted with command line before or used GitHub. And so for us, it was a huge question of how do we actually, we could see the outputs that are achievable with this. And I felt like it was just critical to figure it out. And so that kind of led to the creation of some of the other things that exist now.
So look, but then tell me everything about it. I mean, in a sense, you say very, very critical questions like how many pictures can I take before my computer crash? That sounds a very legitimate question. And I'm sure that along that line, there are many things that you have discovered. What are the learnings that you had throughout this journey of capturing over 2,000 NeRFs over the past years?
Yeah, so it's a great question. And, in the end, I've actually realized that it's almost better to not overthink things in some ways and be able just to kind of go out and shoot. Definitely having certain camera settings and focal lengths is really helpful. And, some of those are shoot as wide as you can. If you have access to like an iPhone with the 0.5, always use as wide as you're able to. If you have a fisheye lens on like a DSLR or mirrorless, I would always opt for that. Having a deep depth of field is super, super important. And the other thing that's probably the most critical thing is a fast shutter speed. When I go back, and it's actually kind of funny timing because just yesterday I found a collection of roughly 200 data sets that I thought were lost yesterday. And, I started to comb through them to look at the individual images that I was using. And a fair amount of them were just completely blurry, which is just like almost like a death sentence to any type of radiance field reconstruction. And so really making sure that the images that you're using are sharp and clear are really critical. But some of the other tips I would say is really, introducing something called parallax, where essentially you can achieve it from just really giving motion in like an arc or like a circle. So it's able to actually understand the scene itself and not just going like side to side. Like that's something that you don't really want to do. But the more parallax and more sharp imagery that you can introduce to your data set is probably going to be by far the most beneficial thing you can do.
Right. And that's the initial part. That is about capturing, right? So capturing the data. But then what about the processing? Because that is another completely different step.
Right. And so, I think we've been super fortunate to see like no code platforms like Luma AI and Polycam emerge, where you can literally just drag and drop now either like a zip folder or just the individual images into a web browser, or you can upload it from your phone. But it's a great question, because if you're going to be using some of the other platforms like say NeRF Studio or Instant NGP, you're going to have some level of familiarity with command line. But at this point now, it's luckily there's a lot of really great tutorials now on both YouTube, and I tried to make a quick guide of just here are the codes I use for NeRF Studio, just to copy and paste or slightly change out what your folder structure would be. This way it knows where to look for.
That I believe we are gonna add directly in the description below. So stay tuned, because you're gonna find it in the description. Mm-hmm.
Yeah, and so there's definitely a lot of considerations though when you it's something that you can choose to pursue as in depth as you would like to. Like for instance, a huge part of the process I would say is actually the pre-processing stage, which is the structure from motion, which essentially is it's aligning all the images within a data set to kind of understand where in the space each image is and which each view is. And so the main method that people use for NeRFs is something called ColMap. And there are additional settings that you can either choose to or not engage with. So there's one called sequential. So if you're using like a video and you're just going to do one giant loop around a subject, then you might want to use sequential, because it's literally going to say like, okay, this is image one, this is image two, and they're all kind of in a row from one another, and it's going to use that sequentially. Whereas there's another mode called exhaustive, where it's just like, well, what if I do 3 loops then? Like, is that going to get confusing and then, you might want to be using exhaustive. But that, of course, comes with, it's all trade-offs, because exhaustive, for instance, has more compute associated with it, and you're going to be waiting longer for it, but you might be getting a higher quality result out of it. And so it's a whole thing in terms of, being able to kind of trade off what it is you're looking for in your output, where, if you don't mind waiting a few hours, then there are certain NeRF methods that you could use, like NeRFacto huge, where you'd be getting a much higher fidelity output. But it's all trade-offs at this point.
Wow. So let me break that in. So you capture. There is one step where you capture the best data sets, and then there are different paths, right? One is, okay, you can go for the web platform like Luma AI, Polycam. Those are great. You can dump them in and you get stuff out. Fantastic. And then there are those other PC based, right? The one where instead you need some level of code and some level of knowledge about what kind of data do you use, what kind of algorithm, let's say, you use for the reconstruction, based also on the kind of data set. And you mentioned a couple. Yeah. So, and how do you make that choice right now, you as someone that has dove into it? Do you tend to lean towards the web platform, like, again, Luma or Polycam, or you create more from PC based?
Yeah, it's a great question. And my answer is a little bit all over the place, because I actually try and put them through as many platforms as I can, simultaneously. But I think for ease of use, definitely Luma and Polycam are by far the easiest. But for me, one of the things that I first fell in love with NeRF creation was, say if you're using InstantNGP, which is NVIDIA's platform, once you actually put in it's like a single line of code, and you hit enter, what you actually end up seeing, and same thing with NeRF Studio, is you actually can watch it explode out from nothing into an actual 3D scene. And for me, I just love that feeling of being able to actually
that is enough just to see that.
Yeah, exactly. And so for me, it's something that I can't really get enough of. It kind of feels similar to watching a film photograph develop within a darkroom. And so for me, I just love that feeling of watching kind of the world assemble in front of you. So for me, that's always, it's always what I try and go back towards.
And this brings me also to another point that is what that we're going to touch later. It's what can you do with this creation that you have made? Because seeing it explode in a way is also a representation of movements, right? And so manipulating and seeing it comes alive in some ways, it's something that we would want. But before we go into it, right, about what you can actually do with these neural radiance fields, the question is, so we started with NeRFs, right? And now, especially if you follow radiancefields.com, that, by the way, you should, if you are not, you should go there and stay up to date and follow it, because, again, also link below if you're passionate about this, is that more types of NeRFs appearing, right? There is MIP NeRF, Keto NeRF, Turbo NeRF, and I'm not making up this. It's actually true. These are actually real names. So how are these all different from each other?
Yeah, it's pretty crazy. When I was first getting started, for me, I was like, okay, there's InstantNGP, and and then there's original NeRF, and those are two NeRFs. And and the more I dove in, it definitely was a certain form of ignorance, because there are hundreds. There are so many different variations now of NeRFs, and more come out every single day, and legitimately every single day. And each one has its own, methodology. Each one has its own, point for what it's trying to accomplish. Where, for instance, there was a paper just a couple of days ago where it was for medical imaging reconstruction, where it's just okay, how do you, set up the resulting data set so that you can view, say, the inside of a patient's stomach or something. So there's all these different use cases and applications for radiance fields, where some use different samples or different methods as well. So say a lot of NeRFs by de facto use something called either ray casting or ray marching. And essentially, what you do is you cast a ray out into space, kind of like you would a fishing line, if you can imagine that. And then, at different points of that fishing line, you would go and you would take samples of what, each pit was occurring at each space in that. And then you would do that for, it's not infinite, but there's quite a lot of rays that are cast out from a lens. But not all methods use that. Some others use a method called cone casting, where it kind of solves other problems like anti-aliasing. But it's also, on the same way that we as users have trade-offs about what we want to use or not use, engineers also have those same trade-offs in terms of where they want to, allocate their levels of compute to, where, say cone casting might be a bit more intensive than standard ray casting, but if you don't use cone casting, then you might be able to allocate some of that compute then to another part of your method. So, everyone within the engineering community, it seems like, kind of has their own thinking about, what's the best way to structure this going forwards, and what would give me the best result. Or it could also be, this is my goal. My goal is to be able to get clean like surface geometry. There's a really cool paper called Uni SDF, which actually introduces 2 radiance fields, each one that does a specific task, and it combines that to create like a stronger output. And so, I think for each engineer, it kind of is just, what's the question I'm trying to solve for, and what's the best components to make that up along the way.
So there are 2 layers. One is the back end, so how these data are processed, and another one is how this actually model functions, or look, these representation functions and look. So, and then based on different ways in which the model looks or the data are processed, you can have different kind of NeRFs. That is basically how I interpret it. Am I correct?
Yeah, exactly. And so you're able to get, just different use cases. And one of the really amazing things about the platform called NeRF Studio is that it kind of introduces a foundational model for, it benefits both researchers and, consumers, because on one hand, it kind of provides a standard foundation for researchers to build on top of. But as they're building on top of it, it just so happens that it'd be able to translate to the actual NeRF Studio platform itself. So like if you take a look at a paper called LERF, which essentially stands for Language Embedded Radiance Fields, where you can, if you had a NeRF of your room or something, you could be like, find me all the plants, and it would go and like highlight that for you. And so because of that, because it's built on NeRF Studio, then you have the benefit of the end user being able to also take advantage of that, where it's incorporated into it at hopefully a certain point.
Mind-blowing. I mean, like you get a NeRF, you get a capture, and then you get a model that already identify like the meaning of objects, right? They kind of like tags them based on what they are, in this case, plants, or might be windows or tables. I mean, I'm not sure at that point, but that I don't see that being far away.
Yes, and it's actually very crazy because there's a follow-up work to LERF that just released named Garfield, where essentially you're able to really drill down in terms of, say, you had like a table from like Wayfair or something, you would be able to explode out the table to actually showcase, like, here are the legs of the table, and here's like the main base of it, and here are all the screws. And then you'd be able to actually, in my mind, provide some level of customer service and support of how do I actually assemble, or what should this look like when it's actually assembled correctly? Because I've always struggled putting together furniture or items that I've bought. And so
you're not the only one.
Yeah, it's just me. But no, I think that all of these, methods, there's really, it's amazing the breadth that you can you can show from these radiance field methods and what they can actually tackle, and the industries that I think that they'll affect.
We're gonna go into that as well. Like, what the point is that you mentioned the speed at which this is evolving. Right. Yeah. And really, if you follow radiancefields.com, and you go there and see new papers daily. Now, there is a gap between the research, what you see there, and what is available, what is viable, and so on, right? So my point is, let's imagine that I am curious, and I am curious, and I want to check this, and I see all this amazing stuff, and maybe I have a data set that is solid, that is there, and I can use, now there is this method, now there is this method. Mm-hmm. How do you go from that level of research and bring it then into something that actually functions and works? If you are a developer, maybe then if you have no coding skills, how can you get that knowledge and get research implemented in an app or a workflow?
Yeah. So I think that it kind of goes back to the value of NeRF Studio, where even Polycam is using NeRF Studio's model as a base to power its Gaussian splatting implementation. And so I think that the answer to that is something that I've also been trying to accomplish through the website, is just trying to create a tighter feedback loop from the actual publication of from the authors themselves to potential end users, where it's just like, okay, well, if we have a healthcare-based radiance field method, how do I get this in the hands of ultrasound technicians or other people within that industry to actually provide feedback, where like what practically would be useful, or is X possible even, because I think on both sides of it, engineers aren't necessarily going to think through the final, the practical real world uses of, oh, I have X situation happen in the real world all the time, but nothing ever addressed. Is this something possible? Whereas, on the flip side too, you have the people who are working in those fields being like, wow, I had zero idea that this was even something that you could do from 2D images.
I just wanted to have a quick break to remind you that the recording of these episodes and many more great conversations with incredible experts are available on YouTube, Spotify, and Apple Podcasts. Just head over to my profile or the episode description, open up the link in bio, and pick your platform of choice. And now, let's get back to the show. Yeah, but then, so that means you find an article. Do they always release code that you can plug into NeRF Studio and then experiment straight away with it? I mean, what are the steps of getting from this research that is published into something that you can try?
Yeah, so it's definitely paper by paper. It depends on the license at which they've attached their work to. Some of them are really permissive in terms of saying like, you're free to distribute, modify, do whatever you want with them. Here's the code. And some also are a little bit more restrictive in terms of saying like, okay, you can use this for educational purposes, for research purposes, or what have you. But depending on the method at which they're built on top of, it's sometimes I think easier than others. Where if say they're building on NeRF Studio, it could be a little bit easier to kind of showcase that because it seems like it's easier to implement. But some other methods are a bit more closed off in terms of what you can try them out for yourself with. But that said, it's been my experience of, when you see papers like that or in any scenario, if you reach out to the engineers themselves, pretty much all of them have been very accommodating to answering questions about like, oh, I work in X and I saw your method does this, is this something that could work? And they've been very responsive and very generous with their time of answering questions.
That's great. That's good to know. I think that the willingness to be open about it, and I think it's just benefit everybody. Again, as you said, also them that probably have no clue. I mean, not no clue, but they don't have a deep understanding of how that specific things might be used in a specific field, right? Yeah. And so you get this reconstruction, right, of reality, because that's to some extent what it is. Mm-hmm. How do you actually edit it? I mean, what can you? I mean, there are two layers. One is how do you manipulate it, edit it, clean it, change it, right. And then what can you do with it afterward?
Yeah, so it's a good question. And so I'll break it down into two different answers for this one, and I'll go NeRFs and Gaussian splatting. So NeRFs are not as editable just yet, but if you use Instant NGP, which is NVIDIA's platform, you're able to go into VR with it. And from there, you're able to edit floaters away using the hand sticks, which is actually very fun. Actually, would recommend trying it out. It's really quite compelling to see radiance fields in VR. And so for those, there have been a couple NeRF papers that have come out that have been published of here are how to edit NeRF. So say if you had a hand and you wanted to like put a finger down, you'd be able to do that. But that hasn't been released publicly. But on the side of Gaussian splatting, there's been a lot of work as well in terms of editing them or creating viewers to put them into a web browser. So some of them are like play canvases, super splat. There's a guy named Antimatter15 who has a viewer, and essentially you're able to take the resulting PLY file that you get after the train Gaussian splat and kind of drag and drop that. And there's also apps like Curia Engine as well, where you have the it's like Luma and Polycam, where you just upload your data set, but that one also has an in-house editor for, say, removing floaters, which are kind of like, you could imagine those bits of information that just aren't supposed to be there.
Yeah. But I want to backtrack a second because you're opening up a world for me.
Yeah.
What are the steps of seeing one of those in VR? Because as everybody know here, like the moment that you merge these two things, that's really what gets me excited. So what would be the step?
Yeah, so it's actually somewhat straightforward. Where if it's NeRFs, you train the NeRF in InstantGP, and then you just connect through Steam Link with your headset, and you're able to go in pretty quickly. The other way to do it is on Gaussian splatting. There's a platform called Gracia VR. I'm not sure if I'm actually pronouncing that 100% correct, but it's very, very simple as well, where, say if you create with Luma and you want to go and, actually Luma does support VR as well now through their web library. But if, say, for instance,
wait a second. Are you telling me that in Luma AI I can watch the stuff in VR?
Not directly through just the Luma platform, but they have a WebGL library that enables virtual reality. And so you're able to take your splat file and view that in VR. I actually haven't had a chance. I don't have a VR headset, actually, so I haven't had a chance to.
We need to fix it, Michael. I mean, come on.
But since it released, I haven't been able to get my hands on one to try it out myself. But it is possible now. And yeah, I actually would be very curious because I have a lot of capture I'd like to try. But
so you were telling me about instant NGP, right? As a step into seeing these splats in VR. Am I correct?
So that one, instant NGP only does NeRFs.
Okay. And then for splats instead?
Mm-hmm. There's one called Gracia VR.
Okay.
Mm-hmm. And then Luma has their web library, which enables VR viewing.
Okay, I have to do so much research after I'm done with this.
Yeah, I
go. Right. Here it goes the weekend.
Well, that's the great part, at least it's gonna be like a weekend, well spent. That's a nice thing. I actually appreciate it when they come out with stuff like this right before the weekend, because then it's like, all right, well, that solves my next 48 hours of time.
Yeah, I think it all depends on perspective of what you like to spend the weekend. Yeah. Not that I disagree. This would be time well spent, but of course.
Right. No, I know what you mean. Yeah. But yeah, so there are a couple of compelling ways to really see these radiance fields in VR. And like I said, it still retains its lifelike qualities as well. So when you're actually going in, the first time I went into VR, actually, I went through one of, a capture of my parents that I had taken. And it actually was significantly more emotionally overwhelming than I thought it would be, because, we've had for the entirety of our lives, at least, modern imaging of just flat 2D images. But now that we have these lifelike representations in 3 dimensions, it's there forever. And now for the first time, we're starting to see our memories and moments in time, and people that are closest to us, this is available infinitely in the future now. And I think that's
absolutely. And this is another thing that it's okay, capturing realities usually has been seen always as a technical thing, right? I mean, it's not always has been seen, but people usually associate it with, I have a machine, now I can make, or I have a bridge, now I can make a 3D model of it, or I have a table, I can make a 3D model. But the point about capturing moments, it's completely different word. And this brings me to my next question, and it has to do with the application of this technology. How do you think, how are currently these used? Does it has a role in digital twin, of course, engineering? What about art, creativity, VFX? What's your take?
Yeah, so my take's a little bit of an extreme one, but my belief is that any time that we currently take a photo or video is a potential use case for radiance field technology, in the way that imaging displayed a moment in time. It only displayed that moment in time from the composition that was set, or from what it sees in front of the lens itself. Whereas radiance fields kind of drop that restriction of the composition and lets it all kind of fall away, and allows the person to actually explore the entirety of a location or of a scene. And so because of that, I think that the amount of use cases that go hand in hand with that are close to limitless, only capped by where we have photography now. I think that pretty much every single industry will be benefited from this, like you mentioned, from digital twins and heavy industry to live events to fashion. There actually was just a couple of days ago this photographer named Danilo who took a few NeRFs of a Kid Supers show in I think it was in Milan, but it's really amazing because you can actually see potential use cases of, okay, here's how the fashion industry would be able to leverage it, and here's you can also take a look at some of the other companies like Google, where Google has been actually very public about its using of NeRFs to supplement Google Maps, where you can go into certain cities, like New York is one of them, where if you want to have, if you want to go work in a coffee shop, but you're like, okay, is this more of a small New York shop where there's not going to be a place to sit, or, there's not going to be like Wi-Fi or whatever, you're actually able to see a fly through of the coffee shop or the bar or the restaurant. And it's a NeRF. And, you're able to actually see in actual detail of what that location is like. And so Google has been very public about saying they've written something like 2 or 3 blogs about it. Apple actually just listed a job description in late December, and in the job description it says, word for word, we're trying to hire someone who has experience in neural radiance fields or Gaussian splatting to provide hyper-realistic versions of Apple Maps. And so we're starting to see now, these trillion-dollar companies that are being surprisingly public on what their plan is for the future. And, I think that extends, beyond them to, just almost every industry where, I see it as having tremendous wayfinding applications. If you're, say, with Google Maps, but then if you're also like a live event company and you've, been stuck and just like wondering, like, are my seats actually like good, or like what's around the stadium by me where I'm sitting? There's so many applications.
There is just one thing. I mean, all those are to some extent always way of capturing reality, to representing it and experience it, or see it in a different place, in a different moment where you can actually not be there. And that's good. I think everybody can understand that. What I am inspired about, it's more this, what's going to be beyond that? Because otherwise it's just like another way of capturing reality. And that is why I think that, for example, art, creativity, and VFX, and what you mentioned about this capturing a memory, capturing a moment, that is where it kind of gets mainstream. Because when something like this gets in the hand of who creates, of my father that wanna capture like his grandson reading a book, for example, that's the moment. Then it's like, whoa,
yes,
we live in the future.
Yes, and so that's actually the reason why I got into NeRFs to begin with, is just like being able to document, events in my life, moments in my life, and yes, that's probably the one that I am by far the most excited about, because to me, it's not like we experience our lives in 2 dimensions, and so for me, it's just like I don't fully understand why our threshold would be limited to just images. It only makes sense that this would be a natural progression of actually documenting life, because that's how we experience it.
And I mean, we're seeing it also, right? Like with the Apple Vision Pro, the first thing that you're going to do is that you can actually use the phone, the 2 cameras that are there, to capture this depth video, right? And that is, I think, one step into that direction.
Yes. Yeah. I was very, very excited when Apple unveiled, spatial photos and spatial videos, because it definitely felt very validating to me in terms of, taking a look at like, where is the future of imaging heading? And like, I think that we have entered into a fundamentally different age now of what is possible versus just a couple of years ago.
And even though, because that has to do with solving a fundamental problem, I think, and that is capturing reality in motion.
Mm-hmm.
Because that is the other layer of it. A lot of what we see, these NeRFs, are static images and static representation. Do you know anything about that, like in terms of research or in terms of progress when it comes to capturing things in motion with neural radiance fields?
Yeah, so the really fun thing about radiance fields in general is that they always seem to exceed my expectations about what I think is possible and when that will be possible, and that holds true with dynamic radiance fields as well. And so we've seen quite a few be published now, where Some of them are like 4K, 4D. There's 4D GS. There is one called space-time Gaussians as well. And there's human RF, and we've seen other companies like private companies like Infinite Realities as well start to publish some of their experimentations with that, where essentially, to explain it, is you can show dynamic moving NeRFs or radiance fields and still have that level of lifelike qualities to it, which is completely mind-blowing to think about. But yes, not only is it possible, but it already exists. And now there's actually there's similar to NeRF Studio. There's a company that created something called Easy VolCap, where we'll see how it progresses. But it seems like their goal was to, similar to how NeRF Studio created a foundational model for static NeRFs, or static radiance fields. Easy VolCap looks like it's pursuing a foundational baseline for dynamic ones, which is really hopefully exciting because, in the way that NeRF Studio helps people build on top of stuff, hopefully it'll be something similar.
Absolutely. And we have been riffing a bit with this idea about spatial computing XR, but in general, because whenever you capture something that is 3D, you want to also, to some extent, experience it in 3D or maybe edit it in 3D, right? So how do you see maybe NeRFs contributing to spatial computing and XR?
Yeah, I think that they're directly linked with one another, and being able to, it definitely seems like there's been a very large shift in priorities to embracing that from some of the larger tech companies, and I think it's going to be just a really versatile tool for these companies to leverage. And I think the end case and use case of that is the actual customer benefiting from it to actually experience it for themselves. So some potential ones that I think, if we take a look at like dynamic ones, if you can imagine, I've seen a couple like exercising applications in VR or XR, but if you can imagine, a trainer even like you can just study their form on how to do like individual exercises, and you can actually get a lifelike 360 view of that exercise and how to do it properly. Or you can flip it around and have the trainer be able to actually provide, the feedback as if they were there. Yeah, exactly. And so I think it's going to be an incredibly powerful tool for, both like spatial and XR. And, other examples would be on the educational side where, there are only so many observation that you can sit in if you are a physician in training for surgery. But if you're able to create these libraries of actual surgeries being done, and you can have people observe them infinitely and across the world and asynchronously, you'd hopefully be having a stronger workforce of physicians. And that's another one that I'm really hopeful about, because I just see it as being such a compelling and better offering than what we have now.
We have covered a lot. And I think maybe you have been following this closely for the past months, years, right? Where do you see this technology going?
Yeah, it's very exciting, and as part of the, I guess, work that I've been fortunate enough to do, I've been able to speak to a couple engineers to get their opinions as well. And I think that we will be seeing a world where, it takes like 15, 30 minutes now to do it. But from what I understand, it is possible to have it be actually instant, where it will just be, like you kind of press the shutter on your phone and you have an image. From what I understand, that is something that is possible and achievable with this technology. And so I think that the future of this is going to be really very compelling. And yeah, I'm curious to see how it all evolves, because, when I first started the website, it was neuralradiancefields.io, because that's just, there's only NeRFs. And the fun thing about this is it could be any single day that a paper is released that completely transforms everything forwards, or it could be a new method. It might not be Gaussian splatting or NeRFs, or it could be a combination of the two. And so I think that the future is really incredible. And there's one paper I'd want to point to as well that also makes me think this is a paper called VR NeRF from Meta. And essentially what they did is they built a camera rig that they had called the Eiffel Tower. spelled like EYE full tower. And essentially what it is something like 22, I think either A9 or A1 Sony cameras. And what they did was they took a fully bracketed, 9 exposure shots, and then they merge each one of those shots into a single image. And then, essentially, so they end up with something like 6,000 images in a data set, each of it that like 60 megapixels or something. And they trained that, and what they found was the fidelity limit wasn't actually like crossed. Like it still was IMAX level quality NeRFs, but it was more of a compute and engineering problem of getting that to work. And so I look at the ceiling as not necessarily being one of a fidelity issue, and more of just as the technology continues and engineering gets better, there's no ceiling. We don't know what the ceiling is on the technology. And those papers are always very exciting to me, because it's just like, it takes an extreme workstation to set it up and power it, but it means it's possible. And it means that we still have an unidentified ceiling. And it's very exciting to me.
Michael, thank you very much for this coverage. And I don't know if being thankful or not about the fact that you all have completely changed the plans for my weekend, that I have to say. But I really appreciate this conversation, all your knowledge. And I indeed, again, invite everybody that's been listening, that is passionate about this technology, that is implementing it in your own workflow, whether it's for indeed digital twins, engineering, creativity, art, VFX, or whatever application you might come in, to actually go and check radiancefields.com, because I think it's a great resource that stays up to date daily, and also provide this information in a way that is digestible, even necessarily for not the most technical people or the engineering. So Michael, you have been great in really unpacking this for us. Thank you very much.
No, yeah, thank you so much for having me. I really appreciate the time.
Thank you really much for listening in. And remember to head to YouTube, Spotify, or Apple Podcasts and check out more insightful conversation revolving around XR and AI. And if you really like the show, please leave a review on Spotify and Apple Podcasts, or a thumbs up on YouTube. It really helps me keep doing this and shine the spotlight on the latest and greatest advancement in XR and AI. Till next time.